Hello, hey everyone. Thank you for coming. Thank you for giving me this this introduction talk. So I will try to just briefly explain what Fluence is and why we are doing this and why it's so cool before Alexei follows you through the workshop. Just a reminder for anyone who missed our first workshop. So first of all, for this workshop, just check you will need npm or yarn installed and also Docker and Git. And I believe there is a link to the Notion page with the workshop detail right now in the chat. So feel free to go there and while I'm talking, just check out what's going to be happening after. And also there will be Rust and WebAssembly needed, but Alexei will explain how to install it properly if you don't have it in the system yet. Okay, so what is Fluence? At Fluence, we are building the decentralized analogy to clouds, basically. So we create the peer-to-peer development stack that allows you to create any kinds of applications or backends with avoiding proprietary cloud tooling or centralized servers or centralized clouds. So when you develop in your application, you fully rely on open source tools and open source stack that Fluence provides. And using this stack, you can create all kinds of from end-to-end peer-to-peer applications to traditional distributed systems and deploy it back to the cloud, but not being really dependent on their managed services or their proprietary SDKs and so on. Also, using Fluence Stack, you can compose different APIs, services, data sources, and I will also without reliance on something proprietary, I will show you some examples of it. And soon when we have the blockchain layer, you will be able to monetize some stuff that you created that other people using in the network. So they're going to be the common network, they're going to be the blockchain, they're going to be payments. So some people will be able to host services for other people. So it all will start working as a decentralized hosting network. And right now, because there is no blockchain yet, there is no incentivization or ability to pay other people to host services. You can create applications, but you will be able to, you'll make sure that you are hosting backend services by yourself, or you know exactly who hosts your backend services. So you cannot just rely on the network to provide you some guarantees about availability of services that you created. And if you think of like what you're trying to achieve here, similarly to how DeFi enabled composability for financial tools and components, we are trying to create the common medium of composability of backend stuff. So you can create different backend services, maybe like a blockchain oracles, APIs, some data sources, compose them together and use them in a common networking execution environment. So the more services created in the network, the easier and faster to create new applications, similarly to how composability works in DeFi. So you can create more complex DeFi applications on chain using the components that were created by other people. Same things here, but off chain and soon to be on hosting marketplace. And at the core of the Fluence stack is the Aquamarine programming language. And this is the new programming language that we created to program peer-to-peer applications and distributed systems. It based on the theory on PyCalculus and basically allow you to create all kinds of, to express all kinds of business logic in terms of distributed services composability, in terms of programming how the how your application has to be executed from service to service, from peer to peer. Similarly, how you usually use Amazon Lambda, for example, when you compose in different microservices in the cloud. So you're saying, I want this user request to go to this service and then execute this function, and then go back to me, and then go to the second service and execute second function, and then put some data to database. Similarly, Aquamarine allows you to do that, but without any centralized place where all the scripts are executed. Scripts are being attached to data packets, and they go to the network and being executed by the network step by step. And it allows you to create everything from simple request response to complex networking algorithms like BFT consensus, Raft, gossip protocols, like any kinds of networking protocols can be programmed using Aquamarine. And the second thing is services. Fluence has services similarly to microservices, but services in the Fluence, they are WebAssembly based. So they have all benefits from WebAssembly, Sandbox. They're fast and their size not huge. It's not a Docker, not a huge Docker containers. It's like a really small WebAssembly based services. They are composable over the network via Aquamarine. They can contain some state. They can be fully stateless, so it can be just some function that calculates you something and lives somewhere in the network on some node. And they are extendable with external data. So you can, when you create a service, you can connect it to external data sources, to APIs, or to decentralized storage. For example, you're creating the chat application that sends messages between browsers, but also saves the messages history into the decentralized storage. So you can create a plugin to IPFS or Skynet or Arweave or anything else, and use Fluence Stack connected with this external storage and store the data there. So the data availability will be provided by this protocol, and your application logic will be executed by Fluence Network. And this obviously works for blockchain data. So you can connect to blockchain, for example, to Ethereum. You can read data from Ethereum, and you can do something, whatever you need in your application with blockchain data. And so Aquamarine is intended to be the high-level programming language that you can see on the right, but it's not ready yet. So we have the intermediary representation of Aquamarine that we call AIR. And it looks like a Lisp-style language on the left, but it's not so hard. So if you're not creating huge and super complex algorithms, it's pretty easy to program AIR scripts, and Alexei will show you a couple of examples during the workshop. Also, a few things. So currently what you can do is this AIR.
You can connect peers, you can discover peers, you can call functions on the peers, you can deploy services to different nodes, and you can do all kinds of networking stuff. So you can set up loops of requests, you can execute them in parallel, you can handle error and get error back to the peer that started the execution of AIR script. And you can have authorization, you can have custom authorization for your application to allow some peers to write into your services and some people not. And so you can find all of this in the documentation. And finally, what you can build with Fluence, and I'll give you a couple of examples. So you can think of anything like from end-to-end peer-to-peer applications like chats, collaborations, like online collaboration, real-time collaboration, gaming stuff that works without backend and just uses network to relay messages, to connect your browser peers and relay messages between them. You can, for example, create something very different, which is like a blockchain, like the Oracle system for blockchain. You can use Fluence Stack to create oracles and to deploy them to some nodes and to read data, to subscribe to data from the chain, and so like use all of this tooling to create Oracle system. You can potentially create the applications that are governed and run by community. And what does it mean? It means that currently when the application has a backend and backends live in the cloud, someone should have the admin, credentials of this cloud. So they're always the person that can switch off the backend of the application. And our hosting marketplace basically allows you to, and the stack itself allows you to build application the way that backend services can be run by many community members. And if you design your application properly, then basically any user can open the front end of your application, which will call one of backend services being hosted by one of community members, and then it would work. So if one of backend services will go down, there are others that can be used to serve the business logic. And it's all can be connected to DAOs on chain, for example, if you want. So it can really go much more comprehensive. And you can create any kind of network algorithms. Some distributed system stuff, if you want to play with air, you can think of any kind of consensus systems or messaging protocols. And so a couple of examples, we have the example of code collaboration application that uses, that connects peers in real time. And it's the analogy of CoderPod application. So you can go to our GitHub and check the repository and see how it was built. And we have the network dashboard, which at the same time is the air-based application, which uses air requests to gather data from the network. And finally, bounties. We have 3 bounties for this hackathon. First 2 really, really simple, and everyone who builds them can get the bounty. So if you use air in any your application, you get the first. If you use air and deploy air a service to the network, you get the second, and best applications get top bounties. And you can see more details if you follow this link about the bounties. And that's it from me. Alexei can just continue with the workshop.